This video will go over the SAT questions from Chapter 3, mostly about parallel and perpendicular lines. In this first problem, these two lines are parallel. So if we think about rise over run, we are rising 2 and running 5. In this other example, we are rising 4, so we double the 5 as well, and we're running 10, which means that P is going to be 10. Given that these two segments are parallel, there is a proportional relationship between these line segments. So 5 is doubled to get 10. We can also say that this one will be 4, and we double that to get 8. They want to know the length of CE in its entirety. So we add together 4 plus 8, and our answer is 12. For number 8, the slope is right here. M is equal to negative 3. So which one of these equations has a slope of negative 3? If I solve each of these for y and put it in that y equals mx plus b format, this is the only one that has a slope of negative 3. For the next one, there is this proportional relationship between the side lengths because the sides are parallel. So 6 times 3 is 18 in the same way that 8 times 3 gives us this entire side length of 24. They want to know what CE is? Well, we're looking at a right triangle. So C squared is equal to 24 squared plus 18 squared. So if we take the square root of that, that value is going to be 30. We could have done that on a smaller scale and figured out 8 squared plus 6 squared is 10 squared, and then tripled that to get this entire length of 30. Either method would work. So first, let's figure out the slope of the line shown. We go down 2 and right 1. So our slope is negative 2 over 1, or just negative 2. If I wanted to find a slope that is perpendicular to that, I flip it, and this is going to become 1/2. I have a point now, 1, 3. So from that, I can figure out my b value. I'm going to plug in 3 for y, and y equals mx plus b. I'm going to plug in 1 for x. I'm going to plug in 1/2 for my m, and this allows me to solve. Turns out 2.5 is equal to b. The y-intercept is the definition of when we plug in 0, what do we get? So the answer is 2.5, or you could think of it as 5 over 2. In this next problem, they tell us these side lengths are parallel, which helps us to fill in some of the angles. This is 115, the congruent of the opposite side there, and these are 65. They are supplementary with 115. We also see a linear pair here. This one has to be 65 degrees because they add together to equal 180. Then they tell us that CE and CD are equivalent. That means we're looking at an isosceles triangle. The base angles of an isosceles triangle are equal. So since that one on the left is 65, the one on the right is 65 also, which means this missing angle is 50 degrees. If I add that together with 65, because they're asking about angle BCD, that gives me 115 degrees. So the answer is B. In this one, P is going to be our transversal. And we have these pairs of parallel lines, J and K, and L and M, that allow us to form some corresponding angles. We know that this one is 40 degrees because it's vertical across the way. And those match up over here. They're also 40 degrees and 40 degrees. We could have figured out all the angles surrounding these, but that's enough. The answer is A. Again, we have two sets of parallel lines, L and M, and S and T. So the vertical and corresponding angles are all going to match up. They tell us that angle 1 is 35 degrees, which means that this is 35 degrees, and so are 35 degrees here and there. We're trying to form a linear pair, so we take 180 minus 35, and the answer is D. So if I solve this original equation for y equals mx plus b, I can figure out my slope. It's a positive 2/3. If I take the opposite reciprocal, I get negative 3/2. The only one of these that gives me a negative 3/2 is this one here. Notice that 3:2 relationship, that 3:2 ratio between x and y. For this one, we are given a set of parallel lines, and this is like our transversal, which means that y corresponds over here. Since they tell us the values of y and z, they are 20 degrees and 60 degrees, we can take 180 and subtract 20 and subtract 60, and whatever's left is x. Turns out it's b, 100. So we're looking for a line that is perpendicular to this equation. So my slope here is negative 2/3. If I want to take the perpendicular slope of that, I flip it, and it becomes 3/2. So that's my slope, 3/2. I also know that this line has a y-intercept of negative 13. So that means when x is 0, y is negative 13. That gives me 1 point on that line. They give me a second point here, 10, comma b. There's a variety of ways to solve this, but let's use the slope formula. I'm taking this as my second coordinate and this as my first up here. I plugged it into this formula, and I want to find out what is a value of b that equals 3/2 once I solve it. So I can simplify my subtractions. If I multiply both sides by 10, I get that b plus 13 is equal to 15. If I subtract from both sides, the answer is 2. For number 30, since we have two parallel lines here, we can draw another line over here and make these all 90-degree angles. And that means that if we're going to say CD is equal to 1/2 AB, let's call AB 2x, and then CD will be x. And this line will also be x. So what we've done here is we've created a special right triangle. We've created a 30, 60, 90 triangle, where one of the legs here is x, the other would be x root 3, and then the hypotenuse is 2x. So that tells me I'm looking at 30 degrees here and 60 degrees here. They want to know angle B. That's this entire angle here. So I take 60 plus the 90, and the answer is A. For 19, my slope is 3. We're looking at one that's parallel, so my slope is still going to be 3. It contains this point. So if I start with y is equal to mx plus b, I can plug in 10 for y, I can plug in 3 for m, and 3 for x, coming from this coordinate over here, plus b. So 10 is equal to 9 plus b, or 1 is equal to b. This is my equation, the 3 and the 1. Because we have these parallel lines, BE and CD, there is a proportional ratio. To get from 3 to 9, I tripled it. So to get from 5 to the side length of this larger triangle, I'm going to get 15. Now I can take 15 squared plus 9 squared is equal to c, the hypotenuse, c squared. And that will help me figure out what that side length is, which will build toward the perimeter. If I round this to the nearest tenth, I get 17.5. So I add that together with 15 and with 9, and my answer is C. So if I pick a few points that are on this line, I can identify the slope. If I rise 3, I run 5. So my slope of this original line is going to be 3/5. They want to know about line M that's perpendicular, or line L, that's perpendicular to this line. So I'm going to take the opposite reciprocal, and my new slope has to be -5/3. So none of these are in y equals mx plus b format. I could move them around to get them there. But I know I'm going to want a 5 with x and a 3 with y, so I can rule these out. And it turns out I need a positive y, like in choice A, to get that slope. In this quadrilateral, if we identify the parallel and congruent relationships, you can figure out we're looking at a trapezoid. So if we call this top base A and this bottom base B, the area, turns out, is equal to A plus B divided by 2 multiplied by the height. And this dotted line here is the height. Now I suppose you could split this up into a rectangle and two squares, or two triangles rather, if you wanted to, but this is the formula to directly get the answer. So maybe I'll pick some numbers. I'll call this one 4, and this is 2, and this is 3. Just making up some numbers. If I was to plug those in, I would have 4 plus 2 cut in half times 3. So 6 divided by 2 is 3 times 3, my area would be 9. Let's try the new shape with these new conditions where my top base of 2 was doubled, so now it's 4. My bottom base of 4 was doubled, now it's 8. And my height is cut into half, so it's 1.5. So I would take 8 times 4 divided by 2, 8 plus 4 divided by 2, multiplied by 1.5. So 6 multiplied by 1.5 gives me 9. Are the areas the same? They sure are. So here we have two similar triangles, ABC and then CDE. That means the side lanes are proportional to each other. And they tell us that BAC matches up with CED, so those are the equivalent angles, they're kind of flipped. And also that ABC corresponds with CDE. So if you think about this line here being a transversal, then we see alternate angles here, alternate interior angles here are congruent. When would those alternate interior angles be congruent? Only if these lines were parallel. AB and DE are parallel lines.